So welcome everybody. I guess we just wait probably a few more seconds to let people in. It's never good to start exactly on time. Better to be a bit late. Okay, so first few information about the AND TechCast days, which this time are more like hands-on labs oriented. We are in the second day. The program for today is in the chat already. In case, keep an eye on the chat. Links will be posted. The agenda is now there. So as a quick reminder, AND UC has a various set of social medias and tools channels. You can join on Slack. You find the links as well in the chat. It will be posted. So just click on it, join the Slack channel, and then the Slack workspace. And then from there, join the channels that you are interested in. There is a newsletter, LinkedIn, Twitter, Facebook. All those links are posted in the chat. So just click on them if you want and just join the community. Few more facts about the subgroup, which is Spatial and Graph Community. So it's a group inside the community itself. It really focuses on Spatial and Graph, especially. There is a dedicated LinkedIn group, a dedicated Twitter account, and also an email address. While for Slack and also the newsletter, it's the common ANDUOC one, so it's a shared one. Feel free to join the Spatial and Graph Community LinkedIn groups and Twitter account, follow it, and get in touch by email if you want. The agenda for today is quite simple. 2 topics, a break in between. First one, we are going to start with the Graph Studio. So it's all about property graphs, discovering Graph Studio. It's a really new tool released only a few weeks ago, or just a few days, can't even remember. And then a break in between in 1 hour, 20 minutes little break. And that after the break, it's special. So it will be Spatial Studio with David and Wayne going through a second lab. Not really spending too much time about the people because you will see us all the afternoon and they will come a bit later. The main goal of this first lab, it's really simple. It's a workshop. Hopefully you're going to do it and not just watch your screen because it's not interesting. So hopefully you set up everything and you are ready to do it yourself. That's the best way to discover and learn a tool in the end. You're going to use Graph Studio, this new tool on top of Autonomous Database. And with Graph Studio, you're going to create, explore, analyze a graph. So you really start from scratch with a simple data set. It's all about finance. So it's bank accounts and transactions. You start from some simple data, loading them, creating a graph, and doing analysis on top of it, all inside Graph Studio, most of it. So the people, I will not read the slide for you because it makes no sense. Let's look at it in a graphy way, in a really simple one. We have a team Oracle with a lot of people on board. The main people being part of this session is Albert, Melly, and Giant. They are all working for Oracle. Albert from France, Melly and Giant from US, I guess East Coast, if I'm not wrong. And for myself, I am the not Oracle one. I'm just linked to Oracle. I'm linked to Oracle mainly being an ACE director. And just because I do Oracle work for the last 12 years or something like that. But I work for myself in my company here in Switzerland, all around Europe and the planet if needed. You have the slide deck. You will also find it on the website at the end. So if you want to read the bio of every one of us, just look at the slides after the session. It's easier. Just one little point about how to run this session. If you have questions, you need assistance, you need help of some kind based on the labs, just use the chat. Just go on the chat and freely post your question, your issues there, and we will try to solve it in a way or another as fast as possible. If it's product question, it's easier if you use the Q&A. So in your Zoom window, you must have a Q&A button somewhere for product questions. If you post them there, it's easier to just find the full list of questions and give a full detailed answers and keep track of product questions. So It will be ideal if you keep this split between chat and Q&A. If you mix up everything and you ask in the wrong place, well, not a big deal. We will manage it anyway. And here it's where I start jumping to Albert, and he will take you through the setup of your cloud account.
Okay, so I hope everybody can see my screen now. Can you? Oh, yeah, okay. So, yeah, setting up your cloud account. As you registered for this workshop, let me put this full screen. As you registered for the workshop, your email has been noted and has been entered in the possibility for you to get access to a Oracle Cloud account with a specific promotion. So it's not your regular, free trial account. It's one that actually has two for you. We don't ask you to produce any credit card, and the free credit you are getting are $500 instead of $300. So the hands-on lab we're going to go through today includes the first step, which is setting up your free cloud account. Then we'll go into a step which is to create an autonomous data warehouse. Then you will import some data, you will create a graph out of the data using Graph Studio, and analyze the graph also using Graph Studio. Now, to start here and to get all the assistance you need so you can actually work on your own, I invite you to go to this place. So bit.ly Graph Dev Live. I'll let it here on the screen just for you to flash it. And I think it's going also to be put in the chat so you can grab it from there. So click this, and that will take you to the live lab. So we have a number of live labs. We have several of them dealing with Graph and Graph Studio. We also have live lab dealing with spatial. We have live labs dealing with all sorts of topics. That's one that is specifically for today's event. It has been a bit fine-tuned, so it's not the same exactly as the one you will find in the regular live labs. It's the same one exists there, but we just fine-tuned it for this workshop. And the first step here is this one. It's getting started. Oh, by the way, you also have some videos that will show you how to do things and help you understand topics. And then getting started. So getting started is all about setting up your cloud account. It says 5 minutes. That's about the time it takes generally if there are no delays and no hiccups. So here you have all the explanation. I encourage you to go through these steps. I'm going to, let's hide this. I want to show this picture. Let me go through just a few screenshots to help you get in there. Now, we have a number of us joining this workshop, and just to make sure that not every one of us, every one of you, go on the same cloud region to spread the load and not have like a massive arrival of tens and tens of cloud account creations, we do it like this. So depending on your last name and the first letter of your last name, we ask you, if you can do that, to use a specific region. So A to G, US, etc., Germany, and London. Okay.
I need to clarify one thing so far. So this emails that have been entered for the promotion are the 45 emails of those who registered on the Ask Tom URL, responded to the email that was sent out requesting that they register there. So I see about, 90 odd people, 45 of them actually registered in time. Those emails were added. For the remainder, I will add the emails today. The promotion is going to continue till Friday. You all will have to watch the lab, and then you can continue to do it on your own starting tomorrow morning. I should have the bulk upload done this afternoon, but it will probably be tomorrow morning when you can create your account and do your lab. You can do the lab if you already have an account, and you're welcome to use an existing account for the lab. But for the promotion, only those 45 who registered on Ask Tom and explicitly give us permission to use their email IDs for this promotion, only those 45 will be able to sign up right now. And then the second thing is I pre-provisioned, I was wildly underestimated this. So I pre-provisioned 10 users on my database. Just please bombard Hans Wieman, and he'll figure it out. I'll leave it to him to decide how he gives those 10 users the account.
We'll do a first
Back to
come,
you,
first serve.
Alexander.
It's as simple as that. Back to you, Albert.
Right. Yeah, and actually there are quite a number of Oracle employees among us. Oracle employees should really use their own cloud account if they have one. Otherwise, you can also use the promotion, but really this is primarily for customers and partners. So Oracle employees, please, if you have your own account, use that one. Avoid creating a new one. So the way this works, you go to this place, sign up .com for users who have not done that yet, and it will prompt you for details. In fact, it'll prompt you for details you see here. So a country territory, which is where you are, your home base, and that is also something that will make the system decide which is your preferred home region, although you should really try and change that to balance the load. Specify first name, last name, and like exactly as Giant has said, enter your email and use that email for you that registered, use the email you use for registering. Okay? At that point, after verifying your email, you will see this box coming up. This will confirm that you have entered the special offer for this particular workshop with the $500 and no credit card. If you don't see that, well, that means either you did not register, or maybe you registered with another email, in which case you should reuse the proper email. Also means more. Either way, write to chat and we will try and give you and set you up with an account, a database account on a database that we have pre-provisioned. Like Giant just said, somehow we didn't expect so many people coming in, joining the workshop without being pre-registered. And so we may need to create more of these. Again, for those who did not pre-register, that offer will remain. We will enter your email into the list of persons who will receive this offer, but you may have to delay registering your cloud account until this has been completed. Eventually, when you are done, when you've gone through these stages, you will be confirmed that you have the special Oracle offer by seeing this box. At that point, you need, or you may want to change your tenancy. Now, this is another special case. This is the case where the email you provided already has an Oracle, is Oracle already associated with an Oracle Cloud account. In that case, rather than using your existing tenancy name, use a new cloud account name. So generate a new one. Like in my case here, when I did this, the cloud account name that was generated for me, so a tenancy name, was constructed from the email. Now, if you already have a tenancy name with that same name, then change that. Enter something else, like albertgoffin.something or a new tenancy name, maybe on Graph Hands-on Lab, and that tenancy will then benefit from the promotion. Also, the home region, that's a drop-down list. From that drop-down list, it is nice if you can then change that to a name which is a home region matching your last name, so that we actually distribute the load. And eventually, you will get the final confirmation. Well, before getting that, you have to confirm some account details, like a phone number and address, and finally agree on starting a trial. Like in that case, I see it says the trial is from Oracle France because I'm based in France, and the final confirmation. And when this is done, you should get this while the account is being set up. So maybe at that point, it's time to take a quick check and see what's happening in the chat, if anybody has problems with this. And we will have you getting started with this.
So I saw already a bunch of messages in the chat, and people are there to take care of it. So if you have an issue for these steps, write in the chat. Somebody's there to help you the best they can. Now, waiting for the accounts to be set up, because it's still not something that happened in just 1 second. So the few minutes that the account have been set up, let's just go through a little intro about what are graphs and what are graph technologies in general, because what's the point of all this lab if you have no idea of what a graph is? So a graph is, I will say simply, just looking at the same information you already have most of the time in a different way. So graph analytics, it's not something totally different than what you have. It's not based on new data. It's just taking what you have and looking at it in a different way, just turning things around and looking differently. A graph data model is extremely simple. It is composed only by 2 elements. One is called the vertices, nodes. They are the rounds. In this picture, you see the rounds, those are the vertices. And then you have the lines. You have those lines, which can also be arrows, connecting all those rounds. Those are called edges. If you think about an existing database, can maybe be, for example, in finance, you can have accounts with transaction between accounts. When you turn them into a graph, the entities become vertices, the connections, the interactions become edges. So you can say all the accounts become nodes, vertices, the rounds. And then all the interactions like ownership, one customer is the owner of an account, or some money is moved from account A to account B. Those are connections, those are the edges. If you think down a different context, for example, at the retail, you have customers, you have products, and you have some sales in between. Customers, they are nodes, vertices. Products, they are vertices as well. You see them as red and yellow. And then what are the edges in this case? The edges are, for example, the orders. If me as a customer, I buy a product, I have an edge that is created between me, the vertex representing myself, and the products that I bought. And it's not just about rounds and the lines and arrows. This is called property graph because every single object, so every single vertex or edge, can also have a set of properties. Properties can be, if you think at an account, can be the name, can be the address of the owner, can be the email address of where to contact the person owning the account. If you think at your shop, it cannot be, again, name and address, but can also be the gender, for example. The most important information is the properties in a property graph. It's just a list. It's a free list of key values. You have one key, one value, and the list, it's totally free. So it's totally flexible, and really it's open to model whatever kind of data you want into a graph. So what can you do with graphs now that you know more or less what it is? There are 2 activities mainly. The first one is querying. When you query a graph, you, for example, just look at how to go from one node to another one, following a given path. So you know that you must go through 5 steps to go from A to B, and you query the graph to find out all the elements that respect these 5 steps. It can also be finding loops, finding cycles, like something that go out from one node to another one and come back, or go through a bunch of nodes and come back. So all this kind of querying based on patterns. The concept of a graph is really the pattern aspect. You query for patterns more than properties like you generally do with your database. The second activity is analytics. Analytics, it's all about running algorithms on top of your graph to generate information which are not there by default. For example, it can be community detection. You have a large social network graph and you want to identify communities, grouping these people together. You can just run an algorithm to detect the communities. There you are. Ranking, which is also actually page rank. If you think at Google, Google is all based on page rank. You can find important nodes inside your graph by calculating page rank with different variants. And then you can also use more advanced tools like machine learning and prediction of the links and prediction of various values. So you can really do a lot of things. And in Oracle Property Graph, by default, you have a bunch of algorithms that are there by default. You will see some in the workshop. There is at least one that is used. And then if you go down to the documentation, you find all the details. Now, some examples of what Oracle customers do with property graph. The financial industry can use graph for many things, mainly for about anomalies detection, fraud detection. You identify a pattern which is not standard. It's not a common pattern of money moving around various accounts. That pattern can represent a fraud. So thanks to the graph, you can easily match every single pattern inside your graph looking like this fraudulent pattern that you identified. You can also use it for manufacturing. For example, you know that to build a product, you have a bunch of pieces that you need, components. And those components are themselves composed by different subcomponents. So by building a graph of all these aspects, you can find dependencies. So which piece do you need to build this final product, and making sure that you have all of them and so on. Other possible needs, inside networks can be like if you think at the internet, for example, your company firewall of you, even yourself at home, you can detect malicious traffic. For example, when a website starts sending you somewhere else because it has been infected by some bad code or whatever. So by detecting patterns between packets that are moving around the network, you can find suspicious activities. Or also if you think of networks from power networks like electric network, or your IT network like switches, routers, cables, and those things, you can identify single point of failures. You can identify sensitive points that you better buy a spare switch because that key switch is really a core component of your network, things like that. And obviously, graphs, we say graphs, say also networks as network of people, network of product, network of behavior. So in marketing, you can predict products, like I can recommend products to my customers based on the full graph of how do they look like compared to other people in my graph. Another example can be data lineage. Mainly with regulation these days, you are more and more requested to know exactly where you create information in your company, where you store it, how you transform it, how you use it. If you think at a piece of information as a piece of a graph, you can track the full life cycle of your information, where it's created, where it's stored, where it's manipulated, and so on. So you can find, oh, I have an information that's just exposed to everybody in the company. That's illegal. I have to go back there to set security on top of it. I have to remove this column. Or also find impact analysis when you have to rename a database table, for example. Thanks to a graph, you can easily find all the impacts if you rename something inside your company. So creating a graph, I'm not going to tell you how to create it. I'm going to tell you what you are going to create yourself in a few minutes. In this lab, in this workshop, you're going to work on a simple data set. It's based on two different tables. You have bank accounts on one side. It's really just a list of accounts. There are not properties inside. There is nothing else. It's really just keep it simple to make it just work. You have accounts on one side, and you have transactions. Transactions, it's super simple. It's from one account to another account, how much is going through. For example, use the first line in this example. It's go from account 1 to account 672. It's 1,000, and so on. So this kind of information is what yourself you're going to build into the lab in just a few minutes. The final result of this graph is this picture. It looks chaotic, it looks random, and it looks rubbish. Say, and what I'm supposed to do with it? You will discover the power of graph, because into this mess, because it's kind of a messy picture, you will find out how graphs allow you to identify interesting information, how to identify new insights that say, oh, this account is actually interesting because of all those reasons, and so on. So the lab really point out, show you how from a big messy picture, a big messy situation, which just looks like no sense, you can actually find the meaning of things and find information that are really helpful and interesting for your business, for example. So this is what you are going to build, and then things will go better and better when you start analyzing it because it starts making sense. And here about querying the graph, I switch back to Albert, which will continue the second part of this intro.
Thank you, Gianni. So yeah, querying graph. Gianni explained how graphs work and what they are, how they look like, what you can do with them. Let's now look at how practically we do these things in terms of, well, languages and APIs and interactions. And also Gianni mentioned that there are two different ways, two different approaches of doing that. One is finding patterns in a graph, and then one is finding like important vertices, highly active accounts, for example. Let's start with the graph traversal or graph pattern matching. For that, we introduce a language we call PGQL. So why PGQL? Well, it stands for Polygraph Query Language. Why QL? Well, the idea of a language that is called QL is probably because it looks a lot like SQL. Sorry. Yes?
Albert, I don't see your screen. In case it's maybe just me, but I don't see your screen.
Oh, sorry. Sorry again. This is sharing now. So let me, yeah, there you go. You should see it now.
Perfect, thanks.
Good, sorry. So querying graph, I was just about to go into what is PGQL. PGQL, Property Graph Query Language, it's called PGQL because it is SQL-like. And the reason we make it SQL-like is because, well, of a large population knowing SQL, and so can learn about that language with, well, some learning experience, but a modest learning experience. So here is a graph. PGQL will help us do these things, is find specific pattern. For example, this loop where an account is transferring money to another account, and from that account, money is going on another account, which eventually comes back to the same account. That is like a naive attempt at the money laundering or fraud. So real life cases are much more complicated, like Gianni showed you some example of it. They can go through multiple accounts and multiple levels of accounts. Or this pattern that involves a bank account transferring money to another account, and all these accounts have got like specific characteristics, like maybe in different country, in different banks or currencies used, or the amount of money transferred will help us identify one specific pattern. And using that, we can now find all the case in my graph, in my really complex graph of hundreds of millions of payments, millions of accounts, tens of millions of accounts, this particular pattern that indicate certain behavior that we decided as suspicious, right? So PGQL, that's a PGQL statement. And I guess you're all familiar, most of you are familiar with SQL, so you understand SQL, or you realize this is really close to SQL. We have a select clause, we have a from clause, or the on graph clause is something that says I want to run this particular match clause, which is really what PGQL is about, so matching graphs on a specific graph. There could be multiple graphs. If there's no graph, it will be just like the default graph. And you can see also that, and so you can do also things like group by, subqueries, distinct, counts, etc., etc. So it's a generally very SQL syntax with that particular clause that indicates it's actually a PGQL graph query language. So the match clause, I like to describe it as being a bit like ASCII art, because if you think about the way you would graphically represent the graph, it will be typically circles for your vertices. That's what the A is or the B is, and then arrows pointing to this between one and the other. And that's what the E1 is. So the E1 is really an arrow pointing between A and B. What this does is essentially read my entire graph. Give me all the cases in my graph where some vertex is going to another vertex, and that's the whole graph, essentially. Now, that's not very interesting. More interesting is this, which does let me select a specific pattern. Actually, that pattern here is really A transferring to B, transferring to C, transferring back to A. So that's actually a loop A, B, C, coming back. So all the loops, which include 3 accounts, will be matching this particular clause. Still not necessarily very interesting because it does not really let me select what are these things. In my account, in my graph, I will end up having multiple kinds of vertices. Like in our account, the one we're going to use, we'll just have, in our graph, the one we're going to use, we'll just see accounts and transfers. In real life, we'll have also the owners of these accounts, like persons or companies owning some account. Also the banks that are managing these particular accounts. And so therefore we need to distinguish what these things are. Now here clearly in our match, we want to talk about A being accounts and E being transfers. That's what we do here by adding a label. So a vertex will have a label. Think of a label of vertex as a table name. So here we only want to find out persons who transferred money to something else, which we don't know what it is. Now that's a bit odd because in reality, transfers will happen between accounts, but we can say a person owns an account which has been a transfer to another account which is owned by another person. Because mostly what we're going to find out when we talk about fraud detection, also the owners, the end users, so person. Now, again, these things are not too interesting in a way because essentially they do fixed pattern match. Like here, just one hop, that could be done using a regular join. That also essentially is a join. That is a more complex join because that would involve multiple recursive queries. Where things get really interesting and when graphs really shine is when we deal with unlimited depth transfer. Like here, we look at something where a person has transferred money ultimately to some other person, but to any depth. So account, transfer, account, any depth. Now that could return a pretty large graph. Now that person is just here Nikita, but still one person has been transferring money to many accounts which have been transferring to other accounts. That could return a massive result set. So we will see that we can actually limit this sort of result. Here's an example, again, our 3 hop cycles, as we just saw on the previous slide, will return all those triangles, all these cases where some money has been transferred from one account to another account to a third account. So money laundering, tax evasion, that's a typical pattern where these take place. And then here, we want to find out all the paths which are 1 to 4 hops away from account 493. Now we could actually write that as a series of single hops, A to B, B to C, B to D, etc. But that can become tedious. Plus you want to have it 1, but also 1, 2, 1, 2, 3, 1. That will be a tedious query to write, except if you write it this way. So here we say find all the cases where money has been transferred from account 493 to any other account by 1 hop or 2 hops or 3 hops or 4 hops. So 1 up to 4 hops. So we now get a more limited usable result set because we're not going to look at all the transfers that have been gone through any number of accounts and giving us the result. So this is going to be useful here for account fraud detection, but also for like dependency analytics in bill of materials. Which part is used by this particular assembly? Given that assembly use other assemblies, and eventually that particular screw. So we can then find out the assemblies actually use this particular screw or this particular part. So this is about pattern matching. Now, also Jenny mentioned that we can apply well-known graph algorithms to accounts, to graphs. In this picture here, we give you a quick summary, a compact list of the 60 out-of-the-box algorithms we provide in our graph implementation. Things for example, detecting communities. So finding out verses which are tightly coupled to others. For example, in a social network, there will be people talking to each other very much. So detecting these communities as people that have maybe the same opinions or that just are in the same club and maybe the same bridge club, but so they talk to each other. So finding these communities. Things like these things, page rank, centrality, closeness, etc. This will help us find out important vertices. So highly used vertices which are highly connected to other vertices. Page rank is a term that comes from Google. So the page rank algorithm is the one that Google still uses in places to make sure that the results we get out of a search are the most important one. So we want to find out the web page which talks about what we are asking for, but that is the most likely to be important. So the one which really is important. And the importance in PageRank is measured by finding out that page which has many edges connecting, so many other pages pointing that page. And the interesting aspect of PageRank is that PageRank has attributes an important that particular web page, and anything else that is pointed by that web page also becomes important. So in other words, an important person that has, or an important blog, for example, that has many people following, if that blog mentions some other blog, but another blog suddenly becomes important by virtue of being referred to by that important page. So pathfinding and also some machine learning algorithms. And here's an example of this. First of all, we start by looking at, on our transfer graph, the important vertex, or the most important vertices. And to find these, we will use a method called PageRank. So analyst PageRank with the name of the graph. And the result is that in our example here, 259 is a vertex with a high PageRank value. So it's very important. Again, very important, meaning that it receives or transfers lots of money. And also it is part of, it is connected to other accounts which themselves have a high PageRank. Right? So then once we have isolated this account as maybe one that we really want to investigate, we're not going to investigate accounts which are hardly ever doing any transfer. We want to find out the one which are doing lots of receiving or sending lots of money. Then we can now use our classic PGQL to find out which cycles is this account part of, in the same way we did before. So by just doing a like 5 up or 6 up in this case analytic, and also which are, so in which path is it part of? So which 1 to 6 transfer path is this account part of? So which money has been transferred from that account that went to other accounts which are 1 to 6 path hops away. Now, doing these things is, you can see there's language, there's PGQL, and there's algorithm to be used. Now, of course, these are all driven by API, so you need to write code to do that. But we make that easy for you by introducing Graph Studio. So Graph Studio is a new offer. It's been available in our cloud for, well, not long, just maybe, I think less than a month now. It's fully managed, and it has two important features. In fact, it's something that is better shown here by looking at how it looks like when you actually start your Graph Studio, and we'll do that during the hands-on lab. The two important parts of that is, first of all, a modeler, because graphs are easy. You can model them easily using a piece of paper or a whiteboard and just start drawing circles and arrows connecting circles with a domain expert. But still, it's something that you need to think about. You're not going to just model things any which way. Like, for example, in a transfer account, in a bank transfer, well, we have persons, we have companies, we have accounts, we have transfers, and we have range between accounts. So that account is managed by that particular bank or that particular branch. That person has these particular accounts. That account belongs to that particular company. All of these things need to be modeled in a clear way. And so that's why we provide a modeler. The modeler is something that will let you choose a set of tables, like here, these channels, cost, country. These are part of the sales history data model that we provide in all cloud databases. So you select tables, and then you tell the modeler to do its way, and it will then figure out or actually propose a possible graph in structure for that particular set of tables. It does that by looking at essentially the referential integrity you have in your relational schema. Like, for example, an account is owned by a certain person, so you have like a foreign key between the account and the account user. Like here, there are also same things in between like products and promotions and costs, etc. And so these will then provide our edges. So generally, to come to transform your relational model into a graph model, the entities, customers, products, accounts, countries, and channels they will become vertices. They are entities between which activity takes place, and the transactions themselves, like a fund transfer, a sale, a shipment, a phone call made in a mobile phone number, these will become edge tables and become edges. Same for foreign keys. So if an account is owned by a customer, that will also become an edge that will say owned by that particular customer. So that's our graph model. At that point, we have the option to create a graph. You see that button on the right top, so create the graph, and we'll go ahead and build the graph. So we create a graph, and then we'll go step by step, load the graph in memory, create a graph from that model, and eventually our graph will be done. At that point, we'll switch to analyzing our graph. And for that, we provide you with a set of notebooks that allow you to do this sort of interaction, so PGQL and running all our analytics. So here's an example of a notebook which lets you do things like this PGQL. So you essentially enter your PGQL. So you have to do that. You have to know what you need to do, and you will then be able to see the result of that PGQL statement, which essentially returns like a kind of a subgraph of what you want to analyze in a visual way. And you can then also interact with this visual way by clicking on the vertex and expanding the vertex, finding out what the vertex is all about, what the edges are all about, what they represent, etc. At that point, it's time for you to get to work. So I'm going to release my share and let Giant take over and show you how this is going to be achieved using the environment you now should have. So your cloud account and a database. So Giant.
Thank you. So let me share my screen. And I was having bandwidth issues, so that's why I don't have my video on. And there's some construction. I seem to run into this whole things happening at the last minute. There's some construction going on just outside. So you may hear some jackhammers are drilling. If that happens, I'll try and repeat what I was saying. So what we're going to do here in the next, well, about 40 minutes that are left is actually, I'm going to walk through the lab. You all can follow along or you can just look at the instructions and do things on your own. For those who are going to register at the Arstorm site today and who will be added to the promotion and will use their accounts tomorrow or later this week, say this weekend, you can follow along right now so that it'll give you some idea of what to expect when you actually do the lab. So I'm going to switch between slides and then actually running through things. So the first step in this, if you have already got the account set up, is to create the autonomous database instance. So the steps for that, they're all explained in the lab itself, but I will just go through the screenshots quickly. So when you log in to your account, you will be on this page where you can say, create an autonomous database. So choose the autonomous data warehouse. So that's the workload, and that's the database we want to create. Enter the information that's needed, or you can leave the defaults that show up. Choose data warehouse as the workload type. Choose shared infrastructure. And then you can click on create that database. There's an optional at the end which says, give information about the contact, etc. You can omit that. but you do need to provide the credentials for the admin user, and you need to remember those credentials. You will be using that. And the network access is going to be secure access from anywhere. But remember this admin user. Then for the license type, choose license included. So give the admin user secure access and license included. And that provisioning will take a few minutes. And once that is done, we will come to the next step, which is creating a user that can use Graph Studio. So while that's going on, I am going to, in the interest of time, go on to actually just doing this lab. Now I need to get out of this guy. One sec, I need to get out of my presentation. All right, can someone confirm that they see my screen with the browser?
Yes, we do.
Okay, so the lab, and then, so when you are at your, you choose the, show me which autonomous databases I have. You choose the autonomous database that you just created. Actually, let me just go back here for a second. You can go to this list, click on show me the autonomous databases. It shows you the one you have. Click on the one you want to use. That is the one you just created. And it brings you to the details page for that database. On that details page for that database, there is a tools tab. And this is the tab from which you're going to access the two things that you need for the lab. One is called database actions. That is the one where you can enter SQL. That's the one where we load the CSV files that we're going to use. That's also the one where you can set up the users. So before you use Graph Studio, you need a graph-enabled user, and that user has to be created in database actions. So we'll go ahead and do that. This is where you need your admin password. So you log in as the admin, and you go to the administration and the database users page, which is where you will create the user. I've created these 10 users, and I'll just walk through the steps. So you click on create user, enter a new user with a password that actually is valid, and that requires the following. It has to be, I think, minimum 12, has to have, oh, I wish there was an option to show it, but it has to have an uppercase, has to have special characters such as underscore or hash or exclamation, etc., and some other stuff. Re-enter the password so that it is the same. Enable graph, enable web access, because you're going to use database actions to load the data. Assign some quota. Simple, just assign unlimited for yourself, and then click on create. So that's the user that you will be using for Graph Studio. And now we'll move to the first part of the lab, which is We've done the provisioning of the autonomous database. The getting started part was actually setting up your cloud account. This part was setting up the database. We've done creating the user. And we're now going to the third step, which is loading the files into the database. So for those who are using graph user 01, 02, 03, etc., you will actually start from here, from this step. Because the first two, you're using a pre-existing database and the user was already set up. So let's go through these steps. You open up database actions. You connect as the graph user. So I'm going to log out over here so that I don't confuse myself, and come back and log in as the user that I'm going to use. It'll be whatever username you gave, graph user or whatever it is you gave. So once I'm logged in, it brings me to this screen where I will now choose SQL because I want to enter some SQL or I want to load some data. So this is the data loading tab here, where you can drag and drop the files that we will download in just a minute. Or if you already downloaded, you can select them and go ahead. So the files that are going to be used are available at this URL. So you can copy that URL and you get the files, and you can go in and unzip and then choose them when you have to upload. So we select to upload, I'm going to select the files. I have already unzipped it. I'm going to take the first one, which is the accounts, the bank accounts. And this will give me a preview of what that is. And I'm going to come in and just do two simple things here. The first is to say that this is a primary key and it's a number. I can optionally go in and change the size of this. I know that it's not more than 128 characters, and I would say next. So I've loaded the file, said that account ID is a number. That's important. Said that it's a primary key. That is useful. And then go ahead and say, okay, I want you to create this. So that one is done. I can then load a second one. To load the second one, again, click on this upload data into a new table. So click on that. Choose the second file, which in this case is the transactions. And the same thing, come in and say the from account, that is the transaction is originating from this account. That's a number. It's going to this account. It's a number. This from account ID and to account ID are the same account IDs that were there in the accounts file that I just loaded. And the amount that is being transferred is a number. The description doesn't really need 4,000 characters. And the primary key in this case is the from, the to, and the amount. Okay, I'm just going to go on mute for just a second here. Okay, couldn't find that. All right. Well, that's worse than I thought. Melly, do you think you can jump to the rescue at this literally last second, or should I just power through this?
We can't hear the noise, Giant. So
Okay.
why don't you continue?
All right, good. That's good. So we've done the loading part, right? So we have now done this part, which is uploaded using database actions, specified what's needed. Oops, I need to fix that one. And so we are done with this lab, and we can move to the next part, which is actually creating the graph. If you want, you can optionally go in and drop those tables that we don't need, etc. So, for example, this simply says what are the errors, if any, and purge it from the recycle bin too at the same time. No, that's optional. So we've done that. Now we can go ahead and create a graph. So the steps here are what we're going to do is we've just loaded this data, these two tables. We're going to create a graph from them. To access the Graph Studio, you either have the URL, your administrator, for example, Hans gave you that URL, or you come in back to the detail page for your database, click on Open Graph Studio. And here you log in with the graph enabled user. Do not log in as admin, log in as the graph enabled user. So graph user or graph user 01, etc. When you log in, it'll bring you to this home page. And this is how you navigate the notebook. This is the Graph Studio homepage. The next one down is what are the models, which means which are the ways in which you've represented a graph from existing tables. That is how you actually create the graph. This will give you the instances of the graph, the ones that you've actually created using a model above. And a notebook is where you can query, analyze, and visualize the graph. The last one, the jobs page, simply tells you the status of some jobs. For example, when you create a model and you create a graph, it'll tell you you're creating a graph. And when it's done creating it, it'll give you the result, saying that it's done. So the first thing we need to do here, and we are now going to this part of the workshop, which is creating a graph from the corresponding tables. So if you click on Start Modeling, or if you click on the models, either one, right? I can click on Start Modeling. So then it shows you the tables that you have. So that's the reason why I wanted to delete the other ones to simplify it. But here I'll multi-select the two tables that I'm interested in. Use the shuttle control to move them over, and then click Next. So what this is going to do is inspect the metadata, if any, and try to use that to suggest a graph. Now, we only put in primary key information, did not put in any foreign key information, so it doesn't know how bank transactions are related to bank accounts. But what we can do, however, is what this will do is give you the create property graph statement. We can come in and simply modify that. And what we're going to do is copy and paste the correct statement, and I'll explain what that statement is and what it does. So what that is going to do is I could have gone into SQL Plus over here, added the foreign key constraints, and then let the modeler do its thing. Instead, what I'll do is actually just copy and paste the correct statement. So we'll take that, put it in here. And the important thing is to then save it. So save these changes. if there was an error in this for some reason, right, if I had account ID instead of to account ID, it would have given me an error message. So in this statement, we're doing the following things. We're first specifying what are the vertices, that is the bank accounts. And the alias for that, or the label for it, is going to be accounts. The edge table is coming from the transactions. And in the transactions, the edge goes from account ID, so that is the source, to the destination, which is the to account ID. And I'm going to label the edges as being transfers. We will use these labels, accounts and transfers, especially transfers, later in the notebook. So it's important to have that. So at this stage, we're ready to go ahead and create. And you can get a sanity check. You can click on it. It'll say the label is transfers. These are the properties of an edge. This is the vertices. That's the label. These are the properties. And I create a graph. We're going to use the name bank_graph throughout in the notebook. So give that name and leave this checked so that once it's done creating, it loads it into memory and then we can continue to use it. At this point, it will take me to the jobs page and it will say that this create a graph from an existing model. This is work in progress. And once it's done, it'll show up on this graphs page. And once it's so up here, that's when we can start to do things with the notebook, which is the next lab. So in this lab, we've created the graph. We're going to verify that we've actually loaded it into memory. So the way to do that is, let me see if the job is completed. It doesn't yet. But when it has completed, which in this case it has, it will now load it into memory, which is not done yet. But once that's done, we can create a notebook. So what I've done here is given folks an option. Rather than do the copy and paste, which is what I'm going to do, I'm going to actually copy and paste every instruction in here, or most of them. You can choose to just get this notebook, again, the way in which you got the CSV files, get it from the object store, download it to your computer, import it, and then continue to use it. Instead, what I'm going to do is I'm going to run through the steps individually. So this job should have completed. It has. And the graph is in memory. I can create a notebook. I'm going to go here, click on create. I want to put this under a folder called learn and give it a name and click create. So we have a notebook, and our notebooks support different types of paragraphs. Each paragraph can execute something. The types of paragraph we have, one is to do text, so that's markdown. Another is to do the PGQL, which Albert was talking about. So that's the property graph query language. That's for graph queries. And the third is to run the algorithms like the PageRank that Albert talked about. So we're going to start here with first documenting what this notebook is about and its purpose. So that's the first part, which is I'm going to copy that enter the text, and then click on execute. So this is to run, to execute a notebook. If you prefer to use keyboard shortcuts, those are documented here. For those folks who are Mac users, you'll actually run into a bit of a problem because things like Command D, for example, will show or hide your, that's one of them, Command D or something, actually is a system-wide shortcut and therefore won't do what you expect it to do. It'll show or hide your ribbon. Okay, so this was the first paragraph. I'm going to turn off the code part because I'm only interested in the actual text. Now, the second thing about navigating notebooks, you can add a paragraph. You can add a paragraph above or below. So hover over the center, you'll see this plus sign, add a new paragraph. So now let's do the first thing, which is we're just going to take a look at the graph just to see what, some of the elements look like, which is a PGQL query, which is simply going to do the following. It is going to look at the first 100 elements, and it doesn't matter what they are. It's going to look at the vertices, edges, so the source, an edge, which indicates a transfer, and a destination. And I'm going to do it on bank graph. That's the name I gave it when I created the graph. So PGQL is similar to SQL, except the from is a match clause which specifies a graph pattern. The graph pattern here in this case is, this indicates vertices, the square brackets indicates edges, that integrates another vertex. So we'll execute that, and when we get the result, we will look at some of the ways in which you can visualize that result. So we'll get a result which should look something like this. Oh, this is nice. They've updated the system. Well, if you want to see the images in full resolution, you can do that. And you can click to bring it back. So I had an instruction up on top, which is now redundant. So we get this result, and this gives us the first 100 elements. Well, one of the things we want to do is to, indicate which accounts are these. Right? So we go to this, which is the settings for a visualization. This here is a setting for a paragraph, and we'll use that a little later. So we'll go to the settings for the visualization. We're going to click on the visualization tab, scroll down, and we'll add account ID as the vertex label. Now you'll have to do this for every visualization. This is not as if the subsequent ones that I do will have this label account ID automatically. This is on a per paragraph basis, this setting. So we've looked at this. So you could if you want, the other thing that you have in this visualization is this choice of layouts. You could try different ones, random to a grid. You can barely see that grid, so increase these numbers. A little more visible there, etc. Now that we've done this, the real purpose of here was what we want to do is look for patterns. And the pattern that we're looking for is a pattern of circular payment or circular transfers, which is it started from some account like this one, went to another account, went to third, fourth, fifth, maybe, and then landed back. But how do we know where to start? Which accounts should we look at? So let's just take some very simple notion over there and see which are the ones that have participated in the most number of transactions, either incoming or outgoing. So what we'll do that, what we'll do for that is simply list, the top 10 with the most number of incoming and outgoing edges. So create a new paragraph, enter that query which says, I want it starting at A, and I want to see how many were the incoming and how many were the outgoing. So that's the in degree, that's the incoming, out degree is the outgoing. And view that. And this is going to give me, because I'm simply asking for scalar information, I'm not really asking for the edges or the vertices themselves, I'm asking for their properties. It's simply going to show it as a table. And I see that 934, 387, these are the ones. So maybe I'll start looking at 934 and see if that has any cycles. So if there are any transactions that are cycles that originate at 934. So let's look for cycles of payment chains of length 5. Now, where did all these magic numbers 5 and etc. come from? That's, some of our customers, that's what they have identified. That fraudulent transactions are often, they have 5 hops or 6 hops, up to 7 hops, but not much more than that. Actually, one of them is actually on this call, I think. Right now, that is the person who found this. So we'll execute that. And here, I want to explain a little bit about this statement. What it is doing is saying, I want to transfer. This is edges that have the label transfers. That's up to 5 hops. It could be 1, 2, 3, 4, or 5. All I need to know is that such a thing exists. I'm not actually looking at where these transactions went. I just want to know that there was such a pattern. If I want to see where these went, let's do that, which is come in here and add a hop, which says, where did I deposit these? Who was the last in that chain, so that I can see how many there are and who was the last one. So this is transfers of length 4 into something other than the account where it originated, and then into the original account. So that'll show you the chain. So now you get an idea of how many there were, 10, 12, 13, whatever number. Now, once again, if you want to see the account IDs, you come in, you add the label information, and that'll give you the account IDs. So we've done this. What happens if you want to see every step along the way? So we can actually enumerate that too. So let's do that, which is go in here and enumerate each one of them. So this is going to, for each hop, so they're going to be 5 hops, the first, the second, third, fourth, etc. Each one of those, it's going to show me the steps. I do want to see the account IDs, but more importantly in this one, because I actually want to see the steps, maybe I should choose a different layout. One that might fit would be hierarchical. So it tells me, I can actually see the steps and see the levels, first, second, third, fourth, etc. Now, it's hard to identify the source. So let's go in and do something about that, which is create something known as a highlight. So I click on highlights, click on new highlight, and I'm going to add a condition which says for the account ID 934, I want to change the size, make that, let's say, 3 or close to 3, so that becomes more visible. Now, in terms of time, I want to do a time check. Jean, this is one logical breakpoint because the next step is a set of algorithms, so maybe I can stop here, or should I race through for the next 9 minutes? Jean, question for you as the MC.
Yeah, you do have 9 minutes left. It's maybe valuable actually just to go on, and for folks who continue to have questions, the team is helping folks on chat.
Okay. All right. So we've used one notion of importance, which is how many transactions, how many incoming and outgoing. We can also use something known as something from the graph algorithms. And in this case, we'd use PageRank to identify which are the important nodes or the important accounts. So to do that, we'll be running the algorithms. And that is using the Java API. So we'll use the Java API. And the first step in order to use the Java API is to get a handle to the graph. So we've loaded the graph into memory. We need to get a handle to it so that we can then run this analysis. And the way in which you run the analysis is you simply say, I want to run PageRank on this graph, and I got a handle to this graph here. So session.getGraph, give the graph name, you get the handle, you execute the algorithm. So when that executes, what it's going to do is it will add a property to every node on the graph. So if I was to, for example, right-click over here, all I see is account ID and a name, right? If I execute this again, I should see a PageRank. Okay, so that PageRank has been added. I can now use that to do the same thing, which is I did with the number of incoming and outgoing. I can simply say, show me.
Just background, the problem with Kagros was
show me the top 10 accounts by way of PageRank. And then we can look and see if this top 10 differs from the top 10. Oh, so this one didn't take the default tabular view. I'll do a tabular view. Since we want to compare, I can change, I want to put things side by side. So I change this. I'm going to add a new one here. And I'm going to come back and simply rerun this query. And put that side by side so that we can see them. Okay, and so we can see that there's, 387 is here, 387 is also on this list, so is 934. But there's some like 222 and 4, which are here, but not here. And there's some over here, like 380 is, which is here, but not here, etc. So we can look into why are those? What's the difference between these two notions? Let's start by looking at 222 and its neighbors. I execute that. And what I'm going to do here is highlight things in terms of the PageRank value. So the first is go back and add the account ID. And the second is add a highlight which says I want to take things with a page rank greater than or equal to a certain amount, 0.0035. And those ones, I'll make them larger. And what you see is that 222 itself has a high page rank. It's also connected to something which has a high page rank, which probably contributed to its value. So even though it may not be participating in a lot of transactions, it's connected to something else, which is also a high page rank. And then we had the 4 and the 380 or 3, right? And see what's the difference between the two. Let's look at those. And execute that. We're going to do the same thing, add account IDs, add the page rank highlight. So let's do that highlight first, since we're here. Condition is page rank greater than or equal to 0.0035. The size 3 or so. And add the account ID. And this itself is useful because you can see that 4 is connected to things that have got a high page rank. 380 is not. So that explains why 380 did not show up in the top 10 of the page rank. And that is the hands-on lab. So thank you so much, and sorry for having underestimated the number of people who want to sign up. I will find a way to look at the list today of those who were on the call. I am going to make an assumption here that if you were on this call, and it means you explicitly are opting in for the promo. That is, it is okay for me to enter your email addresses into the promotion for the cloud trial, and you can then sign up and do the lab at your leisure later this week. The promotion will be active, that is for signing up for the account, will be active till Friday. Thank you. So back to you, Albert.
All right, so I guess everybody can see me again, and let me share the screen as well. Share screen. Continue.
I'm trying to find my, oh, there it is, got it.
Okay, so you should, do you see my screen? Yeah. Oh, no, sorry. Sorry about that. This is okay now. All right. So yes, workshop is completed. That might be a bit optimistic because not every one of you has maybe been able to even do the workshop, but hopefully you'll be able to do it later on. Once your account is sorted out and everything is ready, this will be available for a moment. If it's not complete, you can keep on working. Actually, there are all the live labs you may want to explore as well. Also, for those of you who have the account and have created an AW, one piece of advice is to remember to shut down your cloud resources when you do not use them. Even though the promotion comes with like $500 worth of credits that can let you do use our cloud services for extended periods, still you'll be consuming that money, and you may actually run out faster than you know. So if you're not using your data warehouse, just shut it down and then start it again when you want to use the game. And again, if you can complete today, you can do it later on. That's again on a free account. At that point, we also want to ask you a few questions. Carrie, can you start the poll? Essentially, we want, first of all, to know whether our balance of hands-on versus concepts was good enough. If we need more time for concepts, we have more time for hands-on. or if the balance was okay. Yeah, I guess everybody had a chance to vote now. Let's see what you think. Oh, it was actually, yeah, some of you really wanted more time for practice. Yes, I guess we need to maybe make longer sessions. Now this was already an hour and a half, so we think that's quite long. We could make it maybe 2 hours, or maybe go faster through the concepts. So next question. Were you able to complete the hands-on exercises? Maybe you should have one more question, which is that I was not even able to start them because I didn't get through the account. Or maybe have a question that says, was I able to create my cloud account and the data warehouse in the ADB? Okay, good. So, and I'm happy to see that the majority of you who did not will actually continue on the wall. And I encourage you for doing that and exploring more things. Next questions. Next question. What's your interest in graphs? We assume that if you join this event, that you are interested in graphs, but is that more like at the exploratory level? Or do you have any project in mind soon, later? Good for us to know.
We've shared the results. Can you see them?
Yeah, they showed up for me. Albert, you may have to refresh or something.
Okay, so it looks like Albert's screen has frozen, but we did receive those results, and we will certainly take that into consideration for the upcoming TechCast that we certainly operate.
So while we lost Albert, I guess we can just keep going because we have only like 1 minute left. In this slide, you can find some links. Feel free to visit them to get more information. So the first one is really about the graph product at Oracle in general way. The second one is interesting because it actually answers a bunch of questions. And it's maybe a question you will have yourself at some point. So really visit this frequently asked question page. And the last one gives you another overview of Graph Studio and graphs, a bit like this lab did for you. And now in the last seconds that we have, we can just move on. A&D UC keep looking for people to present the TechCasts. It's every 2 weeks, if I'm not wrong. So go to their website, andouc.org, and then click on TechCasts. Scroll down. At some point, you find a button to just submit. If you want to talk about a project, something you did, submit your presentation. They will be happy to review it and get you presenting at some point. So thank you very much for attending this first lab of the day. Don't leave. There is something else coming up after. In the meantime, just a quick reminder, all those links, follow A&D UC on the various social media, join the Slack workspace. Also, if you have like extra question about graph that come up to your mind in the next days and weeks, there's a graph channel there inside where the graph community hang out, I will say. And now there is a 10 minutes break, and in 10 minutes is the second lab of the day. Thanks for attending this first one.